Chemical bonds. Vocabularies. There are a few vocabularies you need to know. They are chemical bond, ions, cation, anion, and octet rule. Chemical bond is the attraction between atoms that allow the formation of chemical substances that contain one or more atoms. Ion is an atom or molecule in which the total number of electrons is not equal to the total number of protons, giving the atom or molecule a net positive or net negative electrical charge. For example, oxygen, which traditionally as an atom has 8 protons and 8 electrons, making it neutral. However, as an ion, the number of protons still stay the same as 8. However, the number of electrons can actually increase to 9, for example. There are two types of ions, a cation and an anion. Now, a cation is when a neutral atom loses one or more electrons and has a net positive charge. Let's take a look at an example. Lithium has 3 electrons in its neutral state or in its ground state with an electron configuration 2-1. That means that this valence electron 1 can be given up. So if it gives it up, it becomes a cation, which now makes it 2 electrons with a configuration of 2 only. Note that to write the symbol for this, we write Li and then 1 positive charge. Please note here that this is not plus 1 charge, but a 1 positive charge. So it's not a charge. It is an indication of how many electrons is gained or lost. So this is 1 positive. In comparison, an anion is when a neutral atom gains 1 or more electrons and now has a net negative charge. Let's take a look at an example of fluorine. Now, fluorine has 9 electrons in its ground state or as a neutral atom, which is a configuration 2-7. So the valence electron is 7, which basically means that it can gain another electron. So if it gains another electron, it now becomes 10 electrons with a configuration 2-8. And so the symbol for that is now F with a 1 negative charge. Again, note that the negative go behind the number and not before the number. So we've been talking about this octet rule, so let's define it. It is when atoms tend to combine in such a way that each atom has 8 electrons. Atoms want to be like the noble gases with a stable electron configuration of 8 electrons. Remember that the noble gases is group 18. So what we are aiming for in this unit is to learn how to do chemical bonding. And one of the things that will help us is the usage of the Lewis-Dot structure. Now, the Lewis-Dot structure is simply a way that the valence electron is arranged around the element. Remember that the valence electron is the electrons that we need to deal with in order to form bonds. So let's first learn how to draw the Lewis-Dot structure for neutral atoms. So in this case, let's take a look at lithium. Now, lithium has a 2-1 electron configuration as shown right here. So we can see that the valence electron is 1, which is the last number. So let's write that down. So how do we draw it then? So first, to draw it, we're going to write down the element symbol. So we're going to write down Li. Then for each of the valence electron, we will give it a dot. Now remember that the maximum number of dots that can go around the symbol is 8, with 2 on each side. So in this case, since lithium only have 1 valence electron, we're going to start it off by putting a 1 dot on top. And that is the Lewis-Dot structure for lithium. So now let's take a look at the next example, which is neon. And neon is one of our noble gas, and it has an electron configuration of 2-8. And of course, we all know that the valence electron is 8 for the noble gas. So we will write down 8. And we will write the Lewis dot structure for neon, which is basically just Ne plus 8 dots around it. So notice that in putting the dot, we need to put a dot on each side before we put it again. So for example, we put one on top, then one on the side, then one on the bottom, then one on the side. Then we do the next one next to it, again, right there, and right there. And that gives us 8 valence electrons around neon. Now let's take a look at chlorine. Now chlorine has a electron configuration of 2-8-7, so that means that 7 is our valence electron, so we're going to write that down. And then we're going to write down the symbol and put the 7 valence electron around it. And that is our 7 valence electron around chlorine. Now, our last example is magnesium, Mg, which has an electron configuration of 2-8-2. So that means our valence electron is 2. So we're going to write down 2 here. And we're going to write down Mg, and we're going to put the valence electron around it. And that is 2 valence electron around Mg. Now, what happens if the atom loses or gains an electron, which in other words, what if they become an ion? So let's take a look at how we will draw the Lewis dot structure for these ions. So let's take a look at lithium. Remember that lithium has a 2-1 configuration, so that means that it has 1 valence electron. Remember that we want to get to 8 valence electron. So in this case, it is a lot easier for lithium to give up this 1 valence electron than to gain 7 valence electron. So in this case, lithium will give up its valence electron and become a cation. Okay, so we will draw the Lewis dot structure for a lithium ion. So first of all, we are going to write down the symbol. So Li is our symbol. And remember that we initially had 1 valence electron, but because we're going to give it away, there is no longer a valence electron outside there. So we're going to put a bracket around Li. And we are going to put a 1 positive charge. The symbol for lithium ion will be Li, 1 positive charge. Note that the positive go behind the number. The next example is the chloride ion. Now let's take a stop here and talk about why this is called chloride ion and not a chlorine ion. So when an electron is lost, we keep the element name. However, when electrons are gained, we change the name by adding the indent IDE to the root of the element. So instead of chlorine, it becomes chloride ion. Okay, so chlorine, as we can see, has a 2-8-7 electron configuration. That means it has 7 electrons that it currently has in the outermost shell. That means it wants to gain 1 more electron to become to complete the octet group. So we would then write Cl, and we will put the 7 valence electron around it. However, we just gain an additional electron because it's an ion, and we're going to put that right here. We're going to draw a bracket, and now it is a 1 negative charge, and the symbol for this will be Cl, 1 negative charge. Note that if it's just a one charge, we can drop the number 1 in front of it and it just be Cl negative or Li positive. Our next example is oxygen ion. Now, if we take a close look at oxygen, we will see that oxygen is a 2-6 configuration. That means that it can either gain 2 more electrons or lose 4 electrons. Since it's easier to gain 2 electrons, we know that this is going to become an anion. And if it becomes an anion, then it's not an oxygen ion, but it needs to be a oxide ion. So we're going to change that name to become oxide instead of oxygen. And so we're going to write this as O, and we're going to put the valence electrons around it in order to show the number of valence electrons. So we have 1, 2, 3, 4, 5, 6. That we gain 2 more electrons, so we're going to put 7, 8. We're going to draw a bracket around it, and this is a 2 negative charge because we gain 2 more electrons. So the way we will write this now in our symbol is that we're going to write DO with a 2 negative sign. Our final example is magnesium, and magnesium has a 2-8-2 charge. That means it has 2 valence electrons, so it's going to want to give up those 2 electrons. So you're going to write Mg, and then we're just going to draw the bracket around it. And since it gave away 2 electrons, we're going to put 2 positive. So over here, the symbol for that is Mg, 2 positive. And that is how we do the Lewis-Dot structure for ions.